Sound Chapter 14, Physics. From vibration to sound wave, vibration is a to and fro, backwards and forward, movement about a fixed point.
Basically this is the mean position. This is the part of tuning fork, and this will vibrate about the mean position, and the air around this instrument compress, and that compression move forward in all the direction of the tuning fork. Okay, and these are the compressions and rarefactions. Compression and rarefaction. Compression here to here, this is the rarefaction, and this one is the compression. Similarly, by putting the scale on the table, and you can vibrate to produce the sound. Okay,
any object can make a sound wave when it vibrates. Sound can travel in gas, liquid or solid, contain particles.
In this slide, the sound can move through the gas, liquid and solid contain particles. All these things which have some particles, the sound can travel from that object's bodies. And this one is the speaker, and these are the particle concentration of the particles in the compression are more than in the rarefactions, and the compressions will produce the crust, and rarefaction will produce the trough of the wave, and that wave will travel from one point to another point surrounding the that source of sound.
When an object vibrates, it makes the particles next to it in solid, liquid or gas vibrate. As the vibrating object moves towards air particles, it squashes them together, high pressure. As the vibrating object moves away, air particles spread out, low pressure.
Basically this is the longitudinal wave, and high pressure at this place and low pressure at this place, and similarly again high pressure in this phase, and this is the low pressure of the particles. Okay,
as the object vibrates, the air particles also move forward and backwards, and then air particles further away squash and spread out. This makes alternate regions of high and low pressure which travel through air away from the vibrating object. If the wave is plotted on the graph, they make a wave form, shown below.
Okay, this is the graph. Basically, as I already discussed in the previous slides, where the concentration of the particles are more than other region of the space, which is represented in the wave form by drawing a crust. This one is the crust, and where the particles of air are not saturated as compared to the this region, that region will show in the wave form like the trough. So this one is the trough and this one is the crust, and trough and crust are moving away from one point to another, but the particles still stay on that place. Not particle move from one place to another, just vibrate about the mean position, this one and this one, this one and this one. Okay, and these particles will shows that the energy moving from one place to another, but particles still same. Okay, and here the maximum and minimum, here maximum and minimum, which is the amplitude of the vibrating particles, the direction. Okay, this is the speaker and air molecules.
Sound travels in all directions. Sound cannot travel through vacuum, no part. particles.
This one is the glass jar and this one is the bell, and the sound, when the bell will ring, the sound will travel from this glass jar and we can hear the sound. Okay, and when we remove all the air from the vacuum pump, then bell will ring again, but the sound cannot travel from this jar due to these all the material particles were removed, and so we cannot hear the sound of this bell. Okay,
Detecting sound waves. Ear is the organ of the body that detects sound waves. The ear is divided into three parts: A. Outer ear; B. Middle ear; C. Inner ear. Outer ear, middle ear, inner ear. Ear drum.
this one is the outer ear, here to here, here to here. This part is included in the outer ear, and this one is the inner ear, and this one is the middle ear, and this one is the very sensitive part of our ear, which is eardrum. By vibration of the body will produce the vibration in the drum, and that drum will convert that vibration to the signal, electrical signals, through these bones, and here these are the nerves which are going towards our brain, and which convey the message to our brain, and we can listen the things. Okay,
Sound waves reach the outer ear. Sound waves pass through the auditory canal. Sound waves reach the eardrum and make it vibrate.
these all are the stages, basically stages to conversion of the sound to electrical signal, to convey the message to our brain, to listen the things or listen the sounds, different sounds. Okay,
Waves pass from the eardrum to the three ear bones: hammer, anvil and stirrup. The bones vibrate and transfer the vibrations to the cochlea. Cochlea sends the vibration to the fiber, responds to a particular pitch, fiber stimulates the nerve ending, nerve impulse is sent to the brain where we become aware of the sound.
okay, these are all the different steps to conversion of sound to electrical signal, and which are most important for MCQs. Okay, now I'm going towards the next slide.
If very loud sounds enter the ears, the vibrations in the ear fluid are so strong that they damage the fibers and stop the nerve endings being stimulated. This can produce permanent ear damage or deafness.
These 2 points are most important for permanent ear damage or deafness.
Reflect: why do people put a hand to their ear when they are listening to someone who is whispering? Why people wear ear protectors in shooting activities? Oscilloscope, an instrument that allows us to see waves produced by sound.
This is the electrical instrument, which is fast graph plotting instrument. Okay, by taking the input it will plot the graph.
Describing a wave displacement/distance graph is used to show the different position of particles when a sound wave is produced.
Basically this is the describing of wave. Displacement, distance graph. This one the displacement from mean position to extreme position. This one is the crust and this one is the trough, and any consecutive to crust having the wavelength. The wavelength of the wave is can be determined by the taking the distance between two crust, consecutive crust, or basically by taking the distance between two consecutive trough. Both are called the wavelength, and this one is the displacement from the mean position to extreme position. The distance between mean position to extreme position is called displacement or amplitude. Okay, and this one is the distance here to here, here to here, mean position to any point of to the wave. Okay, these are called displacement, but the maximum distance from here to mean position to extreme position is known as amplitude of the wave. Okay, so in this graph we can see that this one is the wavelength. Wavelength is basically, I already discussed, the distance between two consecutive crust or distance between two consecutive trough is called wavelength, and it will represented by lambda. Okay, this one is the wavelength, and this one is the y-axis. Here you can see that y, this is the maximum distance from mean position to extreme position is called amplitude of the wave. This will maybe here by taking the crust and maybe by taking the trough. Okay, both have same sense of amplitude. Okay,
Crest trough. Particle at position X, rest position particle at position Y, move the maximum distance in one direction. Particle at position Z, move maximum distance in the other direction.
okay, these are all the three axes. Basically this one is the x-axis, and this one is the y-axis, and this one is the z-axis, which is perpendicular to both two axes, mutually perpendicular. These all the axes are mutually perpendicular to each other. X-axis having 90 angle between them with y-axis, and y and x both are mutually perpendicular, means having 90 angle with z-axis. And similarly we can say that z and y are are also perpendicular to the x-axis. So these are the position of the particles or vibration of the particles, and which is already discussed in the previous slide. This one is the distance, this one is the displacement, and this one is the amplitude. Okay,
X, Y, Z. Two characteristics of sound waves: A. Amplitude, height of crest or depth of trough. B.
basically this is the definition which is already discussed. The highest or height of the crust or depth of the trough is called amplitude. This is another wording. Okay,
Wavelength, distance from top of one crest to the next / distance from bottom of one trough to the next.
okay, this one is the distance from one top to another top. Basically top is known as the crust, and bottom is known as trough. You can write down definition from here to here or here to here. By taking the crust or by taking the trough, you can define the wavelength of the wave. And this one is the figure, that is the crust, that is the trough. Okay, and this is the distance, this one is the displacement, this one is the amplitude, and this one is the amplitude. Okay,
Crest trough. The loudness of sound. The loudness of a sound is related to the movement of the particles.
okay, the movement of the particles is known as the loudness, and loudness can be measured by different ways.
The loudness of a sound is measured in decibels.
This one is the unit. Basically decibel is the unit of loudness, which is most important for MCQ. Underline this one and mention on your book or notes. Loud sound.
Sound, large amplitude, large amount of energy.
So in the loud sound having large amplitude and large amount of energy. Okay,
quiet sound, small amplitude, small amount of energy.
And the quiet sound, small amplitude having and small amount of energy. Okay, these all are the MCQs.
The sound wave energy is changed to movement energy in the eardrum and ear bones. Loudness and deafness. Very loud sound, strong vibration, can cause a hole in the eardrum, strong pushing and pulling force. Eardrum, perforated, does not vibrate properly. The eardrum can heal and normal hearing restored.
Basically these are the two figures of the eardrums, and this one is the normal eardrum, and other figure we can see that the eardrum was damaged by the more loud sound, and this one is the defected eardrum, and other one is the normal eardrum. The defected eardrum having a hole in it, and this will produce no vibration and we cannot listen any sound.
If exposed to a particular note for a long time, the person will no longer be able to hear it. This is due to the nerve damage of the nerve ending in the cochlea for that note. A common cause for partial deafness is the development of ear wax. The ear wax can be removed under the medical supervision of a nurse.
Okay, this one is the wax inside of our ear, and we should remove this wax by very sensitive way to make safe yourself and to make safe your eardrum. Okay,
Ear gets blocked by wax. Accidents or loud bangs can damage the eardrum. Middle ear can get infected. Older people's bones may fuse. Nerve cells in the cochlea degrade with time. Loud noise may damage the cochlea. This can be treated with antibiotics. This might repair itself. This prevents vibration. There is no cure for this. Signals are not sent to the brain. A doctor.
these are basically matching columns, and you should keep in your mind or learn the matching column. And as this one is attached by this one is attached by this one, and this one is attached by this one, you should keep in your mind, and you should learn the table accordingly.
Can wash this out. How might our ears become damaged? A high pitch sound, a low pitch sound. The shorter / longer the wavelength of the wave on the trace, the lower / higher the frequency of the sound. The more waves you see, the higher the pitch / frequency. Pitch or frequency.
This is the pitch and frequency, and this one is the figure for high pitch sound having high frequency. Okay, you can see this in this figure, very high frequency. Okay, and this one is the low frequency, and low frequency having low pitch sound.
Which trace represents the highest pitched sound? A is the highest pitched sound because it has the shortest wavelength / most number of waves visible. Oscilloscope traces B.
This is these two graphs are basically oscilloscope traces. Okay, and this one is having less pitch, and this one is having more pitch than this figure, or high pitch having high frequency, and this one is having low frequency. Okay,
What can I hear? Increase frequency of signal on the generator whilst keeping the volume the same. The lowest frequency I can hear is under.
this one is the lowest frequency which can I hear. Okay, 20 hertz to 20,000 hertz. Okay, these two values are most important for MCQ. The lowest frequency which I can hear 20 hertz, and the highest frequency I can hear is 20,000 hertz. Or you can also write down this digit by 20 by placing the prefix here. These three zeros can be converted into kilo, and we can say that the 20 1000 hertz is equal to 20k hertz. Okay, this one is the MCQ. So going towards the next slide.
Moths, elephants, mice, humans, pigeons, bats. Hearing ranges of animals with
These are some frequency ranges, and human can hear the sound from 20 hertz to 20 kilohertz. Okay, and as different animals having different frequency ranges which they can hear. Hearing ranges of animal are different for different animals. Okay, hope you are understand these all the points. If you have more any question, you can ask to me in Google Classroom, or you can comment in the comment box. Allah Hafiz.